Have you ever wondered how a car can drive itself, or how a robotic arm in a factory can assemble a smartphone with perfect precision? Or maybe you've just seen a cute robot vacuum cleaner zipping around a house. All of this, from the incredibly complex to the simply helpful, is part of the amazing world of robotics. So, what exactly is robotics? At its heart, robotics is where engineering meets artificial intelligence. It's the science and art of designing, building, and programming machines, called robots, that can perform tasks automatically. Think of it as giving a physical body to a computer's brain. Let's break this down. It all starts with the engineering part. This is the physical creation of the robot. We're talking about the body, the skeleton, the muscles. Engineers have to think about what the robot needs to do. Will it roll on wheels, walk on legs, or fly with propellers? They select materials like metals, plastics, and composites to make it strong yet lightweight. They design the mechanical systems, the gears, joints, and motors, which are called actuators. These actuators are what allow the robot to move, to lift, to grip, and to interact with the world around it. It is a huge challenge to mimic the incredible efficiency of a human hand or the agility of an animal, but that's what mechanical and electrical engineers strive for. But a body is useless without a way to perceive its surroundings. This is where sensors come in. Sensors are the robot's senses. Cameras act as its eyes, allowing it to see and recognize objects, faces, and obstacles. Microphones are its ears, enabling it to hear commands or detect sounds. We also have touch sensors that can feel pressure, temperature sensors, and even sophisticated sensors like LIDAR, which uses laser light to create a detailed 3D map of the environment. All this sensory data is crucial for the robot to understand what's happening around it. Now, we have a body that can move and senses that can perceive, but how does it make decisions? This is where the magic of artificial intelligence, or AI, comes into play. AI is the brain of the robot. The data collected by the sensors is fed into the robot's computer processor, where AI algorithms get to work. At a basic level, the programming might be a simple set of rules. If you see an obstacle, stop. But modern robotics goes way beyond that. Thanks to machine learning, a subset of AI, with machine learning, a robot can learn from experience. For example, a robot learning to sort objects might initially make mistakes. But each time it correctly identifies an apple or a banana, it reinforces that knowledge. Over thousands of repetitions, it becomes incredibly accurate, faster, and more consistent than any human could be. This is how self-driving cars learn to navigate complex city streets by analyzing millions of miles of driving data to understand how to react in almost any situation. So, you have the engineering of the body, the sensors for perception, and the AI for decision-making. When these three things come together seamlessly, you get a robot. It perceives the world through its sensors, thinks about what to do using its AI brain, and then acts on that decision using its motors and actuators. It's a continuous loop: sense, think, act. Let's look at some real-world examples to see this in action. In manufacturing, huge robotic arms perform repetitive tasks like welding, painting, and assembling products 24/7 without getting tired. They use vision systems to see the parts and precise motors to manipulate them with sub-millimeter accuracy. This is a classic example of sense, think, act. In medicine, we have surgical robots that assist surgeons in performing incredibly delicate operations. The surgeon controls the robot's arms, but the robot can filter out the surgeon's natural hand tremors, allowing for much finer, more precise movements than a human hand alone could manage. Some are even using AI to identify tissues or highlight problem areas during surgery. And what about exploring places humans can't easily go? We send robots to the deepest parts of the ocean and to the surface of Mars. The Mars rovers, like Perseverance, are geological robots on wheels. They use a whole suite of scientific instruments as their senses to analyze rocks. Their AI brain decides which rock looks most interesting, and their robotic arm then drills into it to collect a sample. They do all this semi-autonomously because the communication delay between Earth and Mars is too long for direct real-time control. The field is evolving at a breathtaking pace. We're seeing the rise of cobots, or collaborative robots, designed to work safely alongside humans in shared workspaces. We're also seeing huge advancements in soft robotics, which uses flexible materials to create robots that can squeeze into tight spaces or handle delicate objects inspired by animals like octopuses. And of course, there's the AI side. As AI models become more powerful, robots are getting smarter. They're starting to understand natural language, so you can just talk to them. They're developing better common sense reasoning, allowing them to adapt to new, unexpected situations instead of just following pre-programmed instructions. Imagine a robot helper at home that you could ask to tidy up the living room. It would need to understand what tidy up means, recognize different objects, and figure out where they belong. We're not quite there yet, but we are getting closer every day. From the industrial giants on the assembly line to the tiny nanobots being developed for medicine, robotics is a field that is fundamentally reshaping our world. It's the ultimate fusion of physical engineering and digital intelligence, a quest to create machines that can not only do work for us, but also assist us, explore for us, and help us solve some of humanity's biggest challenges. The next time you see a robot, remember the incredible blend of design, sensors, and code that makes it all possible. Thanks so much for watching. If you found this journey into the world of robotics fascinating, don't forget to hit that like button and subscribe for more deep dives into science and technology. See you in the next video.